Chapter 16, review for test. Number 1. Which diagram best represents the charge distribution on a neutral? So the key here, when we're reading this, is neutral electroscope, when a negatively charged rod is held near it. So this goes back to our lab. So first of all, they all show negative rods. So remember, it's not touching it, it's brought near, and we want to see what's going to happen. Well, this is negative. So this, even though the electroscope is initially neutral, what's going to happen at the end? At the end, we're going to see all the positive charges are going to be attracted to this negative electroscope, and then because the positive part is up here, down here we're going to have the negative, and they're going to repel one another. So remember, these are opposite, and then that's the same. So the answer here is choice C.
Why is this?
And on the worksheet, this is the worksheet that we did yesterday, the one that showed the electroscopes on the back when we did the Van de Graaff generator. Okay, number 2. So the answer to number 1 was C. Number 2, a glass rod is given a positive charge by rubbing it with silk. The rod has become positive by, first of all, there's only one particle that moves. The one particle that moves are electrons. So first of all, I'm going to cross off this and this because protons don't move. Now, let's look at this for a second. If I have a glass rod and it has the same number of protons and electrons, it's neutral. If the rod becomes positive, that means that the rod did what? It lost an electron to have a positive charge. If you're not sure about something, you draw a picture, and drawing a picture like I just did, I drew it neutral, 3 protons, 3 electrons. I saw, well, it has to be positive, it has to lose one of these, and then I say, oh, it's obvious, I'm going to be losing an electron. Because when you visualize stuff, it helps you to understand it better. Number 3, which part of an atom is most likely to be transferred as the body acquires static charge? Well, guess what? None of those things move, so the answer obviously is C, electron. Number 4, which procedure will double the force between 2-point charges? So the equation, I'm going to write down the equation. I'm not going to do this in my head. I'm not going to guess. I'm going to say F is equal to K Q1 Q2 over R squared. So it says which one of these is going to double it? Well, if I look at the equation, R is in the denominator and it's square. Okay? So the answer is not going to be to double the distance, nothing with the distance. And then if I have one of the charges, the force is going to be half. So I see that the 2 charges, Q1 and Q2, are both directly proportional to the force because they're in the numerator. If this doubles, that doubles. So the answer there is going to be B, doubling the magnitude of one charge, because I see that they're directly related. Number 5. Which diagram best represents the electric field surrounding a positive charge? So the answer here, this is simple, is A. And what do I know? Then I know that for positive charges, it points away from. For negative charges, it goes toward them. Or, so this you could say is outward, and this is inward. Okay? Number 6. Which diagram best illustrates the electric field around unlike charges? So we know that charges that are unlike, that we know that that's going to be a negative and a positive, and we know that they're going to attract one another. Okay? So when I look, the attraction, So first of all, I'm going to cross off this choice, and I'm going to cross off this choice, because I'm looking for an attraction. Now, these both are an attraction, so now I have to say to myself, it always goes what? Out of the positive and into the negative, so that's how I know this is the choice. That one has the opposite, so the answer is B. Number 7, a point charge of 3 times 10 to the negative 7 coulombs is placed 2 times 10 to the negative 2 meters from a second point charge, Q2, 4 times 10 to the negative 7. What's the magnitude of the electric force? So I want to find the electric force, so I'm going to say F is equal to K, Q1, Q2 over R squared. So that's going to be equal to 9 times 10 to the 9 Newton meter squared per Coulomb squared times Q1, 3 times 10 to the negative 7 times Q2, which is 4 times 10 to the negative 7, divided by 2.0 times 10 to the negative 2 meters squared. So when I do all that on my calculator, it comes out to be 2.7 newtons, which is choice A. Number 8, which procedure will give an electroscope a positive charge? Well, if I touch it with a neutral object, that's not going to give it a positive charge. Bring a positively charged object near it, well, I'm not transferring the electrons. So the key word there, you see how it says near? Because once I take that away, it's not going to make it positive. The key word here, remember, this says near. So to make it positive, I'm going to have to touch it with the positive object. And then negative's not going to make it positive. So I have to read my choices to see that that's choice D. Number 9. When a rubber rod is rubbed with fur, the rod becomes negative. So the key here, you have a lot of stuff here. Oh, it's rubber. Oh, I'm using fur. The key here is that it says the rod becomes what? Well, there's only one thing that moves. So the answer here is going to be electrons to the rod. And number 10 is, in the charging of a solid, charge transfer is accomplished by the displacement of, we know that the only thing that moves is electrons. So these multiple choice are kind of simple. And that's our review sheet.